Hello guys, welcome back to my YouTube channel. I am Suprita Kyar, currently pursuing BE in Sri Venkateshwara College of Engineering, Bengaluru, in the Artificial Intelligence. My ID is 23CA1686. I am studying first sem in the section of DO, and today's the topic is linear algebra, and the course title is Mathematics 1 for CSE stream, and the course code is BMATS101. Today in this video, we are gonna discuss a detailed information about linear algebra. Let us see an introduction. When you take a digital photo with your phone or transform the image in a Photoshop, when you play a video game or watch movie with digital effects, when you do a web search or make a phone call, you are using technologies that build upon linear algebra. Linear algebra in turn is built on two basic elements, the matrix and the vector. Let us see the history of linear algebra. The study of linear algebra first emerged from the introduction of the determinants. Determinants were considered by Leibniz in 1963 and subsequently in 1750. Gabriel Cramer used them for giving solutions of linear systems and now called Cramer's rule. Later, Gauss further developed the theory of solving linear systems by using Gaussian elimination. The study of matrix algebra first emerged in England in the mid 1080s. Linear algebra first appeared in American graduate textbooks in 1940s and in undergraduate textbooks in 1950s. Why linear algebra is important? Linear algebra is vital in multiple areas of computer science because linear equations are so easy to solve. It converts large number of problems to matrix and thus we solve the matrix. Uses of linear algebra. Linear algebra can broadly divided into two categories. The first one is linear algebra for spatial quantities. Here you are dealing with two or three or four dimensional vectors and you are concerned with rotations, projections and other matrix operations that have some spatial interpretation. This is the kind of linear algebra that comes up, for example, in a computer graphics and physical simulations. The second one is linear algebra for statistics. Here, you are dealing with a vectors in a high dimensional spaces that have no particular spatial interpretation and you are interested in matrix decompositions and so on. This domain includes signal processing, statistical machine learning and compression. Let us see some examples for linear algebra in network models. Determine the current 1, 2 and 3 for the following electrical networks. This is how the numericals or an example will be in the linear algebra of network models. Linear algebra in cryptography. Encryption and decryption require the use of some secret information, usually referred to as a key. Example, let the message be prepare to negotiate. We assign a number for each letter of the alphabet. The message becomes prepare to negotiate as shown in the image. The each alphabet is assigned with each number, that is 16, 18, 5, 16, 1, 5, so on, that goes until alphabet E in the sentence that represents a number 5. The linear algebra in a computer graphics. In computer graphics, every element is represented by a matrix. All the images can be represented in a matrix format. The right side images are shown that every image is represented in a matrix form. Linear algebra in a video games. Linear algebra is the study of a vectors. If your game involves the position of an on-screen button, the direction of a camera, or the velocity of a race car, you will have to use a vectors. The better you understand the linear algebra, the more control you will have over the behavior of these vectors. In games, vectors are used to store positions, directions, and velocities. Here are some two-dimensional examples as shown in the picture. The position vector indicates that the man is standing 2 meters east of the origin and 1 meter north. The velocity vector shows that in 1 minute, the plane moves 3 kilometers up and 2 to the left. The direction vector tells us that the pistol is pointing to the right as is shown in the figure. Importance of linear algebra in various categories. Very important in computer vision like camera modeling, epipolar geometry, calibration and self-calibration, pose estimation, structure for motion, and many other things. And it is also very important in a machine learning like dimension reduction, example principal component analysis, and the clustering, prediction, recommender systems, example collaborative filtering. Conclusion: there are so many applications of linear algebra in a computer science, from a single circuit solving to large web engine algebra, especially in the generation and formation of computer coding schemes. Therefore, linear algebra is a course in a mathematics which is subfield in theoretical computer science. Of course, linear algebra is also useful in secondary programming like in computer graphics, database systems, and IP address design, etc. Here is the video of a linear algebra. I hope you understand and enjoy this video. Please like, share this video. Thank you.